Hello, my name is Kyrillos Ayoub, and today I will be presenting my arc length project from Mr. Walsh's AB Calc AB class. For this project, I will be tracing a path in my homeland country, Egypt. I found a passion for running starting in the 6th grade, or the year 2013, when I decided to join my middle school track team in the spring. Starting out as a sprinter, my coach and I recognized that distance running would be a better option for me for the following season, so I set forth a goal to begin running a few miles every day starting in the summer. Ironically, however, that summer I would be visiting Egypt for a month, and I would have to find a path to run along. Although I was unsure how many miles I was running, I found a path that would take me about 30 minutes to run, approximately 4 miles if I ran it twice. To solve exactly how long my path was, I will be using calculus, more specifically the arc length formula, to calculate the distance of the curves. I will add the curves and straight path distances to get a total distance from my summer running path during my visits to Egypt. So just a little background information. My running path is in Sidi Gaber, Alexandria, Egypt, by the shore across from my family's house. Often I enjoyed running along the shore and by the waters where the scene was nice. Nothing is like running by the shore in Egypt, by the way. Sometimes I would run to church as well nearby where all my friends would gather and play soccer. Moreover, it is a very populated area in Egypt, so I was never by myself along the water. So like you see in the first slide, here's a picture of my path from Google Maps in satellite mode. Over here is the water. There's a line of stores along the shoreline. There's a soccer field where some of my friends and I would play, and the church. So the following here are my straight line measurements that I was able to calculate using the Google Maps ruler tool. These 3 lines measured 665 feet. These 3 lines over here measured 1290 feet. This line over here measured 630 feet. The line over here measured 1250 feet. And then these 4 lines over here measured approximately 2,323 feet. To continue measuring the entirety of my path, I will now need to use the arc length formula to measure the nonlinear parts of the path. So to begin, I took the parabola parts and I put it on a coordinate axis. The x-axis is along the shoreline, and the y-axis splits that respective shoreline in half, and I was able to make coordinates of all the key points. So the length of the shoreline is about 660 feet. So the endpoints of the shoreline are negative 330, 0, labeled as point A, and 330 feet, 0, labeled as point B, as noted in the diagram. The 2 points are 660 feet away from each other, just like the width of the shoreline. And to find point C, I started off at point A, and using the rule measurement tool on Google Maps, I went 330 feet to the right towards the origin, and then continued the measurement downward until I reached the parabola. That gave me a total measurement of 455 feet, but because it accounted for the 330 feet from the horizontal measurement, I did 455 minus 330 to get 125 for the vertical measurement. Using quadratic regression on the Desmos program, I plugged in the founded points from the previous slide, and it gave me the following equation displayed in the slide. Over here, I was able to take the derivative. The arc length formula is displayed right underneath that. And then my bounds from the previous slide were negative 330 feet to 330 feet. 1 plus the derivative found earlier, squared. And then the square root of all of that. It gave me a length of 718 feet approximately. Once again, for the second arc length, I took the parabola parts and I put it on a coordinate axis. The x-axis is along the shoreline once again, and the y-axis splits that respective shoreline in half, and I was able to make coordinates of all the key points. So the length of the shoreline is about 1,050 feet. So the endpoints of the shoreline are negative 525, 0, labeled as point A, and 550 feet, 0, over here. I'm sorry, 525 feet, labeled as point B, as noted in the diagram. The 2 points are 1,050 feet away from each other, just like the width of the shoreline. And then to find point C, once again, I started off at point A, and using the rule measurement tool on Google Maps, I went 525 feet to the right towards the origin, and then continued the measurement downward until I reached the parabola. That gave me a total measurement of 670 feet, but because it accounted for the 520 feet from the horizontal measurement, I did 670 minus 525 to get 145 for the vertical measurement. Using the quadratic regression on the Desmos program, once again, I plugged in the founded points from the previous slide, and it gave me the following equation displayed in this slide. So the equation that the program gave me was this. I took the derivative. Here's the arc length formula. From the previous slide, my bounds were negative 525 to 525. The derivative over here, it gave me an approximate length of 1,100 feet. For the third length, I took the parabola part and I put it on a coordinate axis. The x-axis is along a fieldless line, and the y-axis once again splits that respective field line in half, and I was able to make coordinates of all the key points. So the length of this field is approximately 1,875 feet. So the endpoints of the field line are negative 937.5 feet, 0, labeled as point A, and 937.5 feet, 0, labeled as point B, as noted in the diagram. The 2 points are 1,875 feet away from each other, just like the width of the field. And to find point C, I started off at point A, and using the rule measurement tool on Google Maps, I went 975.5 feet to the right, towards the origin, and then continued the measurement downward until I reached the parabola. That gave me a total measurement of 1,637 feet, but because it accounted for the 330 feet from the horizontal measurement, I did 1,637 minus the 975.5 feet to get 661.5 for the vertical measurement. Using quadratic regression on the Desmos program, once again, I plugged in the founded points that we located in the previous slide, and it gave me this following equation. I took the derivative of that equation, plugged it into the arc length formula, and it gave me an approximate length of the arc, which is 2,445 feet. For the fourth length, I took the cubic function part and I put it on a coordinate axis this time. So the past three arc lengths, the past three arcs have been parabolas or quadratic functions. I found it best to make this a cubic function since it represents the general shape of one. The x-axis is across the street, and the y-axis splits the straight line in half, and I was able to make coordinates of all the key points. So the length of the street is about 360 feet, so the endpoints of the straight line are negative 180, 0, labeled as point A, and for point B, 180 feet, 0. To find point C, I started off at point A, and using the rule measurement tool on Google Maps, I went 180 feet to the right towards the origin and then continued the measurement, this time upwards, until I reached the parabola. That gave me a total measurement of 275 feet. But because it accounted for the 180 feet before from the horizontal measurement, I did 275 minus 180 to get 95 for the vertical measurement. In a similar fashion, I found point D and point E using the ruler measurement tool on Google Maps. This time I used the cubic regression program on Desmos. I plugged in the founded points from the previous slide, and it gave me this following equation. I took the derivative of that equation, plugged it into the arc length formula, and for this curve, it gave me an approximate length of 533 feet. So then to find the total distance of my summer path in Egypt, I took all the straight line measurements that we found in one of the earlier slides. I got a total approximation of 6,158 feet. And then I went back, I took all the 4 arc lengths, I added them together. It gave me a sum of about 4,798 feet. So then I took the straight line measurement totals and all 4 arc length totals, and it gave me an approximate length of 10,956 feet. I converted that to miles by dividing it by 5,280 feet, and then it gave me an approximate 2.075 miles. In comparison to Google Maps traces my path to be about 2.08 miles, and my calculations as shown in the previous slide resulted in an estimate of 2.075 miles. So in conclusion, more often than that, I used to run my path 2 times, approximately 4.15 miles, during my visits to Egypt over the summer.